Hi. So, welcome to Infrastructure as Cake without cake. So it's all about testing your configuration management in the kitchen with sprinkles and love, which I'll explain what that actually means. So just a quick overview of what we're actually going to be covering. So we're going to start with a crash course in what config management is and why you'd want to use it. Then we're going to talk about writing cookbooks with Chef, the utensils that you can use in Chef, which is all the tooling, the actual deployment methods that you can use to get your Chef cookbooks onto a machine and actually start configuring things. Then we'll have a few questions if there's anything on your mind. So about me, so last year I graduated from the University of Nottingham and joined Capital One as a software engineer. So over the last year, I've been working on our identity solution, and as part of that, we've used an off-the-shelf system that requires a lot of configuration. So as part of that, we're basically looking at what tools to use, and Chef is a tool that we use internally, have all the infrastructure for, so we decided to play around with that. I've also previously done config management with things like Bash, so as I start, I will be comparing a bit with Bash and bashing it because it doesn't fit all the roles. And since playing around with Chef, I've also tried out Ansible. I won't be comparing it with different config management tools. I've only really used Ansible and Chef, so we won't be talking about the differences. So in terms of what configuration management actually is, just a few questions for all of you. So raise your hand if you know the term configuration management and what it means. Okay. Has anyone here used Chef? Has anyone here used any other config management tools? Does anyone deploy either an application or a website regularly, for some definition of regularly? Okay. So if you're deploying your application, do you deploy that using config management? Is that just something that happens? Cool. And then, has anyone used or has experience with Ruby? Okay. So syntax may not be quite as alien. So this is a cow. This is a pet cow. Having a lovely afternoon, doing some reading, and just having a great time. These are cattle. So cows are cattle, not pet. And this is the same thing with your servers. So if you've ever heard the term pet servers, it's where you basically got this server that you go on, you make some little tweaks to, maybe you've downloaded your configuration files, you've installed all the software that you like to work on when you're working on the server. But that means that over time, that server has changed massively from what it should be. So if that server were to die, you would then, A, not be able to very easily get it back up to what it was at, and also you probably would be a bit annoyed that it had gone down, and you should be very happy with being able to kill your servers and spin up a new one straight away. And shouldn't be worried if anything like that happens. So in terms of config management and what it is, so it's about creating a repeatable, controlled fashion to make changes to a server. So I'm using the term server. It can also be like your local machine, but primarily it's used for servers and deploying applications. So there's also a way to maintain the parity between environments. So often you'll have, say, a staging and a production environment. You may have other environments as well. But generally, you want your staging and your production environment to be exactly the same. Often that isn't the case, but this is where something like config management comes in, because you can literally have, say, one cookbook that configures everything exactly the same way across both environments. And then you can be sure that you are literally getting exactly the same machine, just potentially pointing to a prod environment. So in the continuous delivery book, it's described as The objective is to have everything that can possibly change at any point stored in a controlled manner. So this is obviously the end goal because there are so many things that can change. So for instance, there can be things like DNS, there can be what version of the application you're deploying, there can be all the dependencies, and though they're all loads and loads of things that can change, but to get to the end state, you need to actually start practicing config management. So you're building quality-driven software. You're building something that you want your customers to love. You want to not get called up in the middle of the night because everything's broken. You're deploying that software. But you should also be deploying with the same quality-driven config as the quality-driven application. Because, for instance, if you're deploying this great, perfect system, does absolutely everything that your customers want, but it's got the wrong file permissions, it's not going to work. If you've got, say, SSH with root access open on your box, it's all well and good having your application perfectly secure from all sorts of bugs, but if someone can literally just walk in and own your machine, what's the point? So the other one is, why can't I just use a shell script? So often you will find that, for instance, on AWS, when you're spinning up an instance, you have the user data, which is basically just a bash script to set up your machine. And that's not often good enough because, for instance, it's not testable. The only way to know if it's going to work is to run it. So there's no concept of unit testing. There's no concept of doing any checking ahead of actually running it on a box. And so, for instance, if you're, say, a company that pre-bakes machine images, so for instance, on AWS, you have AMIs, Amazon Machine Instances, images, sorry. So if you're baking those and pushing them out to the whole fleet, you want to know that they're going to work. But if you don't have any confidence in that bash script that may set everything up, and you're going to break everyone's machines and everyone's servers across everything, that's probably not a good idea. The other one is in terms of tooling. So one thing with using an actual config management tool is you get a load of tooling out the box. So you get things like linting tools to find common errors. You get unit testing and integration testing to actually check that things work the way you think they're going to. Whereas with the bash script, generally what happens is you will have your own custom way of doing things. And so there may not be easy ways to actually work out the problems that you're going to have. The other one is versionable artifacts. So this isn't saying that you can't just have a bash script with version 1, version 2. This is saying that, again, linking in with the tooling, you can have things that automatically detect if you're breaking the API for someone. And if you practice semantic versioning, you can actually detect that and automate the bumping of your semantic version. It's also the fact that you're using a real language. So for instance, something like Ruby, which Chef is based on, has its own standard library, its own package ecosystem that you can take advantage of. It already has years of experience, best practices, and ways to do things that you can take advantage of. It also means that you can do things like proper code reusage and, as I say, libraries. So Bash does have a package dependency system, but shouldn't, because Bash isn't really one of those things that you should be using for your core infrastructure. It's great to start off with, but as you start building out, it's just going to give you more problems than not. It also allows you to expose a domain-specific language, so things that actually provide some abstractions over some of the common functionality. So do you really need to know whether you're installing on, say, an Ubuntu or a Red Hat image? And if so, do you personally need to know every single command line argument for every single package installer? Probably not. You can just use something that abstracts that all away. You just specify, I want a package to be installed with this name, and it then does the rest. So the other one is templating languages. So when I've previously used Bash for this sort of stuff, I've literally just done like a find and replace for a variable in text files. But when you get into using an actual templating language, which you can use with Bash as well, is the fact that you can do things like give it lots of input and it can loop over it, it can do conditionals, so you get a lot more power than just regular find and replace. So what happens if you don't have it? So I host a number of WordPress sites for some customers, and I host it on a VPS with a provider, and about a month or so ago, I had an issue where the VPS locked up and I couldn't get on. A few hours later, I get an email saying, so the hypervisor's bust, we're gonna have to kill it. And so when that happens, I try rebooting the machine and it's all gone. None of my data's there. Lost absolutely everything. And of course, you're all saying, well, you have backups, right? Didn't have backups. And this is the thing. Fortunately, I had been practicing some level of config management, had a repo with some of my configs, fortunately had a backup of some of the data. But it's the fact that if you don't have that, that could, for instance, put you out of business, and really isn't good. So config management is a way of ensuring that, for instance, it took me 3 hours to get everything back up and running. If I had, say, a cookbook that could do that for me, it could literally be a matter of minutes and I would be back up. Yeah, so it's all about making sure that you can respond to, say, easy fixes and changes. If you need to, say, add 100 new sites, you can do that very easily. Or for instance, if you just got a new hire in, they could potentially do that on their second day. They could add in a new site, and it should be that easy that anyone can just come in and make these changes. So config management itself is not a silver bullet. So just by saying, oh yeah, we've written a chef cookbook to configure OpenSSH, that doesn't mean that all your problems are fixed. There's still a lot of tech and cultural requirements that you have to actually build in to how you deploy software, how you actually build these things the right way. They're also not glorified bash scripts. So I have seen some cookbooks which basically just run bash commands. And that basically means that you lose out on a lot of the features of using config management. So you either use it for what it is or you don't. It's up to you. So in terms of actually writing cookbooks, and there is a couple of bits about the terminology, so I'm not confusing you all. So Chef itself is a Ruby-based configuration management tool. It doesn't actually require any Ruby knowledge. So when I started doing this in January, I had basically never touched Ruby, and there aren't many things that you actually need to know the ins and outs of Ruby, how it works. Because as I mentioned, it's a domain-specific language that wraps around it. So it looks more, it's more human readable and writable than having to know how to do like proper Ruby. And yeah, so within, say, a month or so, I was able to fairly comfortably be writing cookbooks. As mentioned, there's the domain-specific language that makes things a lot easier. And then there's also a lot of stuff that the community have written and released. So as of Tuesday, there were 3,432 community cookbooks. So these are all things that people have released as open source software that you can download and run out the box, and it will install something for you. So you've got things like databases, web servers, language and ecosystems. You've got full applications like things like Jenkins, which can manage both your master, your slaves, all of that. So chefs generally run in a client-server model, but as we talk about how to deploy it, you'll find that that doesn't actually necessarily hold true. You don't have to run it in that model. It's also Apache 2 licensed, so all of the chef software is open source and means that you can use it as you want. So that includes all of the infrastructure, all of the tooling. So if you want, you can just run it on your own infrastructure perfectly well. Alternatively, there are hosted options. So I know at least AWS has their own version of it. Chef software themselves can run it themselves as well. So let's go into the Pantry and look at some of the terms. So there's a cookbook, which is a collection of recipes, attributes, and potentially new resources. So this is, for instance, the Java cookbook, which has a recipe that installs Java. The recipe itself is a collection of resources and logic. So a resource is an abstracted statement of configuration describing desired state for the item. So for instance, this would be package, open JDK, install. So it's fairly well readable. Then you've got attributes. So these are either information about the node or configuration items. So there's a tool called OHI which runs when you start Chef that basically profiles the system. So it does things like, okay, which cloud provider am I running on, if any? What hardware requirements have I got? How many disks have I got? What users exist on the system? Things like that. And then you can also define your own. So for instance, you could specify what version of Java you want to install, whether you want to install it from a URL, whether you want to install it from a package, things like that. Then you deploy Chef onto a node. So a node can be a container, a virtual machine, an instance on, say, a cloud provider. It could be a physical server. It could be like a hardware switch. It can basically be anything that can be connected. So then there's the term converge, which is where you run Chef on a node with a given run list. So the run list is an ordered list of recipes and roles that run against the node. So Chef employs a two-phase converge. So first it compiles, which basically will expand out the run list to all the different recipes it's going to run. It'll remove any duplicates, and then it'll actually run it. Then you've got, for instance, roles. So if you're deploying a web server, and you know you're always going to deploy it with Nginx, with this user serving from this directory, and with these security hardening bits, you can create a role which can either be a Ruby file or a JSON blob, which basically specifies all the attributes and recipes you want to run. And then instead of specifying that every single time, you just say, I want to run role web, for instance, and then that will provision that all for you. So then you store your cookbooks on the bookshelf. There's also a tool in the Chef ecosystem called Burks, which is quite confusing because not spelt right, but you know. As I mentioned, there's OHI. Okay, so does anyone have any questions right now before we start delving into what cookbooks look like? Okay, cool. So the cookbook file structure is fairly interesting. So here we're generating, oh, okay. That just did it on mine. So Chef lets you actually generate a cookbook. So it creates it with all the default files that you want. So for instance, we've got the Burks file. So Burks is a dependency management tool that downloads things from a bookshelf. There's your metadata, which is information about the cookbook itself. So for instance, what platforms do you support? What's the cookbook name? Are there any requirements of Chef versions? Things like that. You've got the recipes. So this is actually what gets in, how you install things on a box. Then you've got your specs. So for those familiar with the Ruby, this is RSpec. So it's a unit testing framework. Then in the test folder, you've got inspect tests, which we'll get to after, which is a way of verifying that your box or your node is installed the right way. So let's cook some welcome muffins. So you've just had a new member of the team join, and you want to welcome them. So you create them a user called, say, Jamie, and then you create a file called muffins.txt in the home directory saying, welcome, Jamie, it's nice to meet you. So this is a recipe in of itself. and has two resources. So the first resource being the user resource, and the second resource being the file resource. As you can see, each of the resources has different properties that you can give to it. And these are all predefined and default to some values if you don't specify them. Yeah. But that's obviously quite annoying because every time you have a new member of the team, you have to create them another recipe. There's no way to configure that. So instead, you can use attributes, which are a way to make it configurable. So in your attributes file, you can default the user to Jamie. But if you, when running your recipe, you can specify the value of that attribute. So you can override user to be, say, Joe. And then it will say create user Joe with the username Joe. And it will basically interpolate that and work out where everything goes. So one thing I mentioned is testing. So obviously this example was just to show you the syntax of what a recipe looks like before actually showing the tests. Obviously you would write it in TDD, which is one of the big things about Chef, is the ability that you can write tests before you write your recipes. And so that's one thing that we chose Chef over other tools, primarily because we can write the tests and have that as part of our infrastructure. So for those not familiar with Ruby, you don't need to look into this in that much depth, but basically what we're doing is we're pretending to run the cookbook on an Ubuntu 16.04 node. We're expecting it to converge successfully. Then we're hoping that it will create a user, Jamie, with the username Jamie, and also that it will create the muffins.txt file. So this uses a tool called ChefSpec, which is an extension of RSpec, the Ruby behavior-driven development tool, and is the primary unit testing tool for Chef. This is where it helps if you've done Ruby before, because some of the syntax is a bit weird, but you do get used to it after a while. Yeah. So as we've done before, we've actually specified so in the previous test, we didn't specify the value of the user. So the user attribute defaulted to Jamie. But here, we're actually overriding it to test. And then we can see that actually the test user is created with the right file. So for instance, one of the great things about unit testing is that you can test out all these branches. And it means that you can test it before you actually converge on a box. So you can see many different combinations of attributes and what will happen when they're changed. Obviously, you don't want to do an exhaustive list because that would take forever. But yeah. So then in terms of the actual utensils that, and tooling that you have to use, so in terms of linting, you've got the first one, which is called cook style, which is, for those who've touched Ruby, is Rubicop, which basically just does Ruby style checking. So it does common errors like you shouldn't be using double quotes because you're not actually using any features of double quote interpolating. You've got an extra comma there that's not actually needed and things like that. Yep, so this is a rebranded version of Rubicop for Chef-specific code, and therefore has its own special, they basically specified which rules to actually enforce. So there are certain general Ruby style rules that maybe don't make sense with Chef. So Chef have basically got their own version with their own tweaks. Then you've also got something called Food Critic. So Food Critic is for Chef-specific issues. So for instance, in this example, so we're basically starting the Tomcat service by directly calling out to the service, or out to the sysvinit service file. So this, first of all, isn't cross-platform. It's only ever going to work when you're on a system that has that file there. Additionally, if, for instance, you have Tomcat 7 installed or Tomcat 8, that's also not going to work. So instead, what you can do is you can use the service resource, which again will do the plumbing under the hood, will immediately give you the ability to run that cross-platform, because it'll understand what in its system you're running on and will then target that. The other one is when you're, say, downloading a file. So commonly you'll, for instance, cd into a directory and wget or curl it. And that's, for instance, the way you do it on the command line in a bash script. But in Chef, you can use the remote file resource, which then performs things like caching. So it'll know if it's actually already downloaded it and be like, well, I don't need to re-download it, so here you go. It can also do things like send different HTTP requests and do a lot of clever stuff under the hood, which just makes it easier and yeah, a bit more convenient than just using the shell commands. So as mentioned, there's also chef spec. So it's an extension of RSpec. So it's the quickest path to actually testing your cookbook. So for instance, if you're just installing some software, so you're installing a couple of packages. So if you do that with an actual Converge, you have to first have an instance already up. So say you've got a virtual machine, which takes, say, half a minute to spin up. So just to test that an install works, you have to spin up the VM, you then have to update your repos, and then you have to install the package. If that package has, say, 100 dependencies, you're going to be waiting a while. Whereas with unit testing, you can literally do it in a couple of seconds. And it basically runs it in memory. It also doesn't know whether things are going to work. So for instance, if you say, I want to install the Nginx package, but that package doesn't actually exist, Chef Spec won't know that because Chef Spec doesn't actually run it, doesn't care. So it's just a way of testing your assumptions. And primarily for mocking and testing your different paths and scenarios. So for instance, in the examples before, when the user attribute's set, I want to do something specific. When it's not set, I want to make sure it does the default action. This also means that because you've done it in your unit test, you then don't need to do it in your integration tests, which the integration tests, when they run on an actual node, take a lot more time. So your unit test itself can do most of the heavy work, can be run a lot more quickly, and then mean your integration tests are more just a sanity check of, has this actually worked? Okay, cool, I can carry on. It also provides matches for your resources. So, for instance, if we go back, so for instance here, we've got a matcher for create user. So we're expecting the chef run to create a user. So this is stuff that is provided out of the box with Chef Spec. It provides those matches, so you can use basically natural language to describe what's happening. The other great thing with Chef Spec is you can test that the right properties are called. So you can make sure that all the different extra configuration bits that you've specified are actually tested against. So in the case that someone comes back a month later and changes the username from, or changes the manage home variable, it will actually flag up and say, my test is expecting that. You probably shouldn't have changed that. Or if you should have changed the test first. So the other one is using context blocks. So these are another RSpec thing, which basically let you wrap a block of code with a context. So for instance, when you're running on Ubuntu 16.04, you want to install the Apache 2 package. But when you're running on Red Hat 7.2, you want to install the HTTPD package. these are just really easy ways of, if you're needing to support, say, multiple platforms, or if you want, say, different error statuses, you can test all of those out very quickly. So for instance, this is the recipe that the previous test corresponds to. So it's a very simple one. It just installs a package. That goes out to all of this code. But yeah. So the other one, as I say, is you can also test for your error states. So for instance, if you have the static type or the static site type set, you want to have Nginx installed, but when you don't have the static, when you don't have the site type attribute set, you want everything to blow up. Again, this is a way to mock out the fact that you need some alternate flows, and this is a really easy and quick way, which again would just be painful on if you have to actually spin up an instance, test that it works, and you get much quicker feedback. And so this is the corresponding recipe. So it raises an exception with that exception name or that content. Otherwise, it installs a package. So then, as I mentioned, there's integration testing. So this is using a tool called Test Kitchen. So as mentioned, unit tests are for assumptions. So when you first write your unit test, you're expecting the chef's going to do this thing, and then it's going to do this thing, and then this thing. But often what's going to happen is you're wrong. So does that package actually exist in your cache? Can you actually create that directory? But that directory is already owned by someone else. Or that user already exists. What do you do in that case? And this is the fact that unit tests can't actually know because it doesn't run it. And so you want your unit tests to cover the first step of your thoughts. And then once you've got them all up and running, you then need to run them on a box and work out if you've actually done the right things. This is what I mean by it's just a sanity check afterwards. So Test Kitchen's got a few different drivers. So there are different ways that you can actually spin up nodes. So if you use a Docker-based infrastructure, you can use Docker. If you primarily work with something like Vagrant, with VMware, you can spin up a virtual machine. If you're deploying to a cloud, you can actually test on that instance. You can make sure that, for instance, if you're deploying it to a specific AMI, a specific version of an OS on a cloud provider, the only way to know it's going to work is to actually run it against that. So these are ways that they literally just hook in and spin it up on that node. And it's a really convenient way of knowing, are things actually going to work in the environment that I'm testing it? These aren't the only ones. When I had a look, there are about 18 or 19 different ways of running your kitchen tests. So this is a kitchen YAML file, which basically specifies how you want to run Test Kitchen. So we've specified that we want to run it with Vagrant, with Chef 0, which basically means I don't want to run against a Chef server, which we'll cover in the next stage. We want to use inspect to verify that it actually works. We want to run it against Debbie and Jesse. And then we just want to run the user cookbook default recipe with a couple of attributes. So you can have as many of these suites as you want, and you can also run them in parallel, depending on, so I've previously locked my machine up because I've had 4 VMs running at 4 gig of RAM with also things like Slack and Outlook running in the background on a 16 gig machine. And I noticed too late and couldn't even power off the machine. It was too late. So there's things like that that you obviously need to be careful of. But yeah, so this will then, so when you run kitchen test, this will actually start spinning through. Sorry, I click. So if you run kitchen list, you can see Okay, you've got one instance. Then you want to create the instance. So this is using a Docker base instead of Vagrant because it's a lot quicker. So this basically creates the instance, then starts to actually install Chef onto the box because it needs Chef to actually install the cookbook. Then once it's done this, slowly copies all the files over for your cookbook, then runs it. It runs a verify, and then it destroys the box. So just a bit slower. So in terms of the converge, so you've got an instance running, and you run the converge, and sorry. So you've got an instance running, you run the converge, and it will literally copy all the files onto the box. Given the run list that you had of the user cookbook and the attributes, it will then specify those, perform a Chef run. Just going to go by pretty quickly. So for instance here, it's created a file called home everybody hello. It's changed the content, it's changed the mode of the file, and then it's finished. So then there's the kitchen verify, which runs inspec, which we're about to touch on, which is basically a way of checking. So just because your converge has worked doesn't mean that everything's actually worked. So Converge could have installed all the right software, but the services may not be started. And basically, things may be broken. So Verify basically checks that actually things are created in the right way. Then you've got a destroy, which just kills the instance. So this is what inspec looks like. It's written to be a human readable and potentially also non-technical readable way of describing compliance and audit. So it's not actually built for Chef. It can be used across anything. It basically confirms that all your nodes are in the right state without installing anything. So it's completely agentless, uses just the operating system software, and yeah, checks on it. So then just very quickly, so we've got the Chef server. So in the client server model, you have a Chef server that your nodes will phone home to, basically say, hey, I'm a new instance, this is what I'm installing. And then what can happen is your Chef server can then be configured to push out configuration to those nodes. So for instance, if Heartbleed's just happened and you need to update your whole fleet and you don't want each application owner to have to push out the change, you can update the Chef server and say, hey, everyone install this package every either half hour or an hour, which is configurable. The clients will phone home and say, hey, have I got anything new? The Chef server will say, yeah, new OpenSSL version, boom, done. So without a Chef server, because often you don't want to have all this infrastructure. So if you want to try out Chef right now, you don't want to have to spin up this massive bit of infrastructure with lots of different moving parts. So what you can do is just install it using Burks. So you literally download your cookbooks, you run Chef locally, and you can install it. In the interest of time, because this took a while to download and install. Yeah, so it then installed it. And this can all be done absolutely locally with no other infrastructure. All you need is a working internet connection and be able to install the Chef client onto the box. So in terms of learning resources, if you want to find out any more, so there's Chef Rally, which is the official Chef documentation, which they've recently been doing some really good work on improving it. There's chef certification, which I'm potentially going to be looking at for next year. There's the Food Fight podcast, which talks about everything chef. And then coming very soon, a shameless plug to a blog post I'm writing on how to actually write chef in a TDD fashion, and how I approach them myself. So just looking at what we've covered. So we talked about what configuration management is, how it works and why you'd want it. Talked about actually how to write it with chef, the different tooling you've got and what you have to help you in writing them, how you can actually deploy it, and I'm not sure we may have time for questions. So if you have anything, I'm Jamie Tanna on Twitter and Slack. I've created the chef channel, and my site is jamietanna.co.uk. Thank you.